Presumably, the history of cosmology is a fascinating journey, and that spans thousands of years, from ancient civilizations to early cosmological beliefs, and the modern scientific understandings of the universe. So let's briefly explore the key milestones in the history of cosmology. Ancient cosmologies. In ancient civilizations, in ancient times, they used to have civilizations, and with these civilization, they're used to have cosmological beliefs. And these cosmological beliefs were often mixed. They were mixed with religious and mythological narratives. Many such cultures, like ancient Egyptians, Greeks, Mesopotamians, they had their own cosmological models that could describe the Earth's place in the universe, and and its relation with the other celestial bodies, with other planets, with other things that were observable to them. And then came geocentric model, probably in ancient Greece, around 5th century before Christ. The philosopher Aristotle, he proposed a geocentric model of the universe. And according to this model, Earth was at the center of the cosmos. That means the center of everything that's observable, that was observable around this planet, was assumed to be moving around it. And Earth was assumed to be the center of this whole cosmos. And every other celestial bodies, including sun, moon, planets, stars, they all orbited around the Earth in circular orbits. Probably in the beginning of third century before Christ, the Greek astronomer Aristarchus of Samos, he proposed a heliocentric model, and suggesting that Sun was at the center of the solar system, and Earth and other planets probably revolved around it. However, this idea did not gain a lot of widespread acceptance at that time, and there could have been many cultural and religious reasons that could have been the constraints in front of this model, this heliocentric model, which was probably placing Sun at the center, and everything else revolving around it, including Earth. And this geocentric model was further refined by ancient astronomer Claudius Ptolemy, nearly in second century BCE. His model was also known as a Ptolemaic, Ptolemaic model. His Ptolemaic system incorporated some epicycles and deferents to explain the observed motion of the planets in the sky. And in the beginning of 16th century, the Polish astronomer Nicholas Copernicus revived the heliocentric model in his book on the revolutions of celestial spheres. It has This modification by Nicholas Copernicus he presented a very comprehensive uh, heliocentric model, and challenging worldwide the geocentric view in this book that he wrote out. And then in early 17th century AD, Johannes Kepler, he was a German astronomer. He formulated his three laws of planetary motion. And these laws provided a mathematical description of how planets move around the sun. That was a beautiful way of doing things, and producing the results from observed data and the models that were incorporated, and sun certainly being at one of the foci of the elliptical order. And so these Kepler's laws, they really came in a formulation where the most of heliocentric system got its confirmation from mathematical point of view. Everybody is aware about the Newton's laws of motion, and uh, his theory of gravitation. Probably in the late 17th century, Newton's laws of motion and laws of universal gravitation provided a profound understanding of forces governing the motion of celestial bodies. And Newton's work laid the foundation for classical mechanics. It laid the foundation to classical physics and the mechanics of the celestial bodies that are there in the cosmos. Expansion of universe, cosmic expansion. In early 20th century, the astronomer Edwin Hubble, he made a groundbreaking observation that showed that universe is expanding. His discovery of redshift in the radiations that were received from distant galaxies provided an experimental proof that most of the galaxies that are there, they are moving away from us, and a very small fraction of the galaxies, the light coming from them, were showing blue shift, indicative of the fact that that they are moving towards the planet. But the majority of the radiations that were received by Edwin Hubble, they were indicative of the fact that most of the galaxies are moving away from us, and indicating some kind of cosmic expansion going on in the cosmos. In the 1960s, the astronomers like Arno Penzias and Robert Wilson, they accidentally discovered the cosmic microwave background radiations, and it's abbreviated as CMBR. And it's a faint afterglow of the Big Bang. And this discovery provided strong evidence supporting the Big Bang theory, and has become a cornerstone of modern cosmology. And people have been receiving these radiations, detecting these radiations, and marking the calculations on their observations, and certainly they are a very strong support in favor of the expansion of universe. that was experimentally observed by Edwin Hubble. Then, nearly in 1980s, the theory of cosmic inflation was proposed by the physicists Alan Guth and Andre Linde. This theory suggests that the universe underwent rapid exponential expansion during the early moments of the Big Bang. So this rapidity, this exponential rapidity, and solved many of the problems that